Welcome to GNN, Geometry News Network. And my name is Ronnie Flowers. Stay tuned. Today we plan on covering some very important news. How exponents are changing numbers quickly. Radicals are pushing numbers out of their homes. We will also recap and get you updated reports on the quadratic formula and the rational problems we face. First, let's explore the impact exponents are making on numbers. Okay, first off, we have x squared times x cubed, and these things right here, these aren't multiplying, they're adding to get x to the 2 plus 3, which gives you x to the 5th power. Wow, man, these exponents are crazy. The second thing going on here, we have x squared to the power of 3, and this gives you these exponents right here are multiplying to get 2 times 3, which is x to the 6th power. Wow! The third thing we have going, these things right here, like x to the 0 power, they must have unified or something, because anything to the 0 power is always 1. Wow! Anything to the 0 power is always 1. That is so awesome. They're just doing all kinds of crazy stuff. Fourth thing we have going on, this little x to the negative 1 right here, this negative 1 is powerful. It makes it move all the way from here to the bottom of the fraction, become x to the positive 1, which is the same thing as 1 over x. Well, then we have the fifth thing going on here. We have y to the negative 2 over x to the negative 3rd. These completely, this goes up to the top, this one goes down to the bottom and becomes positive. X to the 3rd over y to the 2nd power, just like that. And number 6, and the last thing these exponents are doing, they're just being plumb crazy today. X squared over y to the 3rd power to the 4th power. This 4th right here makes it do it to both of these in parentheses to multiply those exponents and get x to the 8th over y to the 12th. Wow! Well, I sure hope you liked that last story about the impact exponents are making on numbers. Here in a moment, after commercial break, you will hear from our co-anchor about all the radical things going on.
When I first get out of bed, start studying those rules of life. My teacher said, recognizing basis, exponents too. Exponents must be positive, negatives won't do. I've got to work those problems, I've got to find a way. Don't you want to learn them today? Exponent rules are not that bad. Just remember this song and don't get mad. Remember that exponents have a set of rules. Use them when canceling, it won't be a fool. Start to see a pattern to how these things are done. I raise to 0 power and the answer's always 1. The base can't be 0, I must remember that. Just 3 more rules to learn, now and then I can relax. I'll put it all together, I'll know it pretty soon. Then I can go watch my cartoons. Exponent rules are not that bad. Just remember this song and don't get mad. Remember that exponents have a set of rules. Use them when canceling, it won't be a fool. See basis, exponents find the sum. Dividing and subtraction makes me almost want to hum. Subtract the smaller power, correctly place the base. The power rule says multiply, parentheses erase. I know I've got these rules now, I know I got them right. I just need to remember them with all of my might. Exponent rules are not that bad. Just remember this song and don't get mad. Remember that exponents have a set of rules. Use them when canceling, you won't be a fool. Use them when canceling and you won't be a fool. Use them when canceling and you won't be a fool. Yeah.
All right, guys. Well, I sure appreciate how well Ron covered the idea of exponents, because radicals are doing strange things just like the exponents, and they're connected. I think their gang activity is coming to the streets. Let me show you what I mean. Radicals are really exponents in disguise. Let me show you what I mean. This is the square root of x, and it's the same thing as x to the 1/2 power. The exponent is 1/2, and the radical is the square root of x. For instance, look at this one, x to the 3/2 power. It's also a radical. It's the square root of x raised to the 3rd power. I'm telling you guys, strange things are happening. Watch what I noticed today. When I was looking at the square root of x cubed, I noticed when they started kicking people out of their house. Anytime you can see x cubed is the same thing as x to the 2nd power and x to the 1. Every time they pair up, they kick one out. So they chose this to write this as x times the square root of x to the 1 power. Look at this situation. I saw this as well. What if we had, it happens even with numbers, 75, x to the 3rd and y to the 5th power. Look what they did. Again, let's take and break down 75. Oops, sorry guys. I had to do some deep investigation to find out why they were kicking these out. 75 is the same thing as 25 times 3. And 25 is the same thing as 5 times 5, or 5 squared. Again, we have a pair. And every time we have a pair, they kick one out because the square root of 25 is 5. I think that's why they're doing it. And they left the square root of 3 inside. Now x cubed, as we said, is x squared times x. Again, we have a pair. And we know the square root of x squared is x. So it came out and x stayed in. And then we have y to the 5th, which is the same thing as y squared times y And again, they knew the square root of y squared is y. And they knew the square root of y squared is y as well. Again, every pair, one comes out. So they wound up kicking 2 y's out and 1 y stayed in. Guys, this is the kind of activity we're seeing going on in the streets where there are radicals. And again, radicals and exponents, I think they're working together. Watch out, guys. Do your investigations and do the deep studying that you need to do. Okay, guys, that's all I have on radicals. Watch out and do your investigations again. I repeat that. But now I'll hand it off to my anchor, Mr. Ronnie Flowers, as he tells you all about the quadratic formula.
Thank you so much, Kim. I sure hope everyone paid attention to the radical things going on that you talked about. Well, next we're going to recap the quadratic formula. Get ready! So, you need to remember that the quadratic formula is used for solving any quadratic equation. For example, here's the example we're going to give you. Solve 3x squared equals 4x plus 9 for x, and you want to leave it as a simplified radical. Just like when solving by factoring, you will want to make sure that you get this equation equal to 0. That means we need to get that 4x off of that side by subtracting 4x, and get that plus 9 off that side by subtracting 9. So we're left with 3x squared minus 4x minus 9 equals 0. Now this is where your A, B, and C comes from. A, B, C. So A is equal to 3, B is equal to negative 4, and C is equal to negative 9. And then you plug it into the quadratic formula. So plug it in, plug it in. We go x equals negative b plus or minus square root of b squared minus 4ac all over 2a So, or you might remember it as x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'll make that b look a little bit better for you there. Alright, so now we plug it in. So we take a, b, and c and we just start solving for x. X equals negative b, so that's a negative 4 plus or minus square root b squared. So this is a negative 4 squared minus 4 times a times c. Make sure you take your time on these quadratic formulas so that they don't mess with your mind. So 2 times a is 3, and then we start simplifying. Minus a negative 4 is just a positive 4. Plus or minus square root of. Negative 4 squared is the same thing as positive 4 squared, so you get 16. Go ahead and put in your calculator, negative 4 times 3 times a negative 9. Now I'm going to do it in my head. Negative times a negative is a positive. So 4 times 9 is 36, and then 36 times 3 is 108. So it's plus 108. All divided by 2 times 3, which is 6. So now I'm going to start coming across the bottom here. We still are simplifying. 4 plus or minus square root of 16 plus 108 is 124 all over 6. But wait, we're not done yet. 124 will simplify because it's a square root. So if you have a square root of 9 and you take square root of 9 and get 3, square root of 16, you take square root of 16 and get 4. Well, 124, I can divide 124 evenly by 4. And when I do that, I get 4 plus or minus square root of 4 times 31. You just put in your calculator, 124 divided by 4, and you'll get 31. Another way you can remember that you could divide this by 4 is that 100 easily divides by 4 to get you 25. And then you've just got 6 more. 24 divided by 4 is 6, so you go 25 plus 6 is 31. That's the way I did that in my head, by the way. And then divided by 6. Now don't forget, now you have to take the square root of 4. So 4 plus or minus square root of 4 is 2. You're still left with the square root of 31, and this is still all over 6. Are we finished? There's a 4. That's the same thing as 2 times 2. Plus or minus 2, square root of 31, all divided by 6. Hey, 6 is the same thing as 2 times 3, wasn't it? 2, 2, 2. They all have a 2 in common. So we cross out that 2, cross out that 2, cross out that 2, because when can cancel? Tell me when can cancel? I can cancel when they multiply, but add or subtract I dare not try. So make sure you realize that the reason why we're able to take a 2 out here is because I could actually rewrite that top as 2 times 2 plus or minus square root of 31 all over 6, or 3 times 2. And what I'm actually doing is canceling out the 2's, and you write down what's left, and then you're done, which is 2 plus or minus square root of 31 all over 3. And that's your answer. And it's in simplified radical form. You don't have to do anything else except leave it as 2 plus or minus square root of 31 all over 3, because we simplified. So good job. And I sure hope you pay attention. So right after this commercial break, Miss Kim Flowers will come back as my co-anchor and talk to you a little bit more about rational problems that we face.
X equals negative b plus or minus square root of b squared minus 4ac all over 2a. X equals negative b plus or minus square root of b squared minus 4ac all over 2a, all over 2a, all over 2a, all over 2a.
X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a.
Alright, thanks fans for coming back. Now I'm going to talk to you about the rational problems you face. Many of you came in on our social media site and told us all about the problems you faced during the homework over the weekend trying to accomplish those rational expressions. So let's look at the details of what you really need to know for the knowledge check. Okay, simplifying rational expressions. One example you may need to deal with is this. You need to factor both top and bottom. The numerator has a common factor of 4, so we will divide 4 from both terms, leaving us with 4 times x plus 9. Now we'll factor the denominator. X squared minus 81 is a difference of squares, so we will factor it into two binomials. X times x gives us x squared. 9 times 9 gives us 81. And if we want the middle term to be 0, one needs to be positive, one needs to be negative. So now you have 4 x plus 9 over x plus 9 times x minus 9. These two are a common factor in both numerator and denominator, so we can cancel them out. 4 over x minus 9, that's your answer. Alright, another problem that I have seen that you guys will need to know and how to deal with is this situation. X squared minus 100 over x squared plus 20x plus 100. Again, same situation. You need to factor the numerator and factor the denominator. When we factor the numerator, we get x plus 10 and x minus 10. When we factor the denominator, we get x in both first places. The factors of 10 that'll multiply to give 20. Well, 10 times 10 multiplies to give 100, and 10 plus 10 gives us 20. Plus, plus, because both are plus. Same sign, and this tells you those signs will both be positive. Now we have x plus 10 on the numerator times x minus 10, and in the denominator we have x plus 10 times x plus 10. Again, we have a common factor. We will cancel that out. This is what we're left with. The answer is x minus 10 over x plus 10. The final situation that you'll need to look at and you'll need to see and know how to do includes division. So let's look at that. You have 10 over x plus 8 divided by 7 over x plus 1 times x plus 8. This has already been factored for you. So you just have to recall that division is the same with fractions is the same thing as multiplying by reciprocal. So this is the same thing as 10 divided by x plus 8 times x plus 1 times x plus 8 over 7. Because this is times, then everything on the numerator is over everything in the denominator. And because we have a common factor in the numerator and denominator of x plus 8, we may cancel. And our final answer then is 10 x plus 1 over 7. But we can take it one more step. We can distribute the 10. So 10x plus 10 over 7, this is the answer you're looking for. This is the most simplified form. These are the rational things you'll have to deal with. I hope this takes care of your questions. And if you have more, keep reaching out to us through our social media site, also known as our email.
When can you cancel? Tell me when can you cancel? I can cancel when I multiply, but add or subtract I dare not try. Tell me how can you cancel? Tell me how can you cancel? Factor the numerator and denominator. If the top and bottom match, then become the slasher. Tell me when can you cancel? Tell me when can you cancel? When factors are the same, we cross out to get 1. Write down what's left and then you're done. That's when I can cancel. Yes, that's when I can cancel. When can you cancel? Tell me when can you cancel? I can cancel when I multiply, but I subtract I dare not try.
cancel. Factor the numerator and denominator. If the top and bottom match, then become the slasher. Tell me when can you cancel? Tell me when can you cancel? When factors are the same and cross out to get 1. Write down what's left and then you're done. That's when I can cancel. Yes, that's when I can cancel. Welcome back. I sure hope you enjoyed that commercial break. And Kim Flowers here. We're together. Just going to recap what we talked about today. Anything else you want to add?
Well, I surely appreciate how well you went over those exponent rules. I tell you what, that helped them when they came to me talking about radicals.
Oh yeah, that's exactly right. I sure appreciate you going over those radicals and all those rational expression problems.
Yeah, and then the quadratic formula came in handy as well. I appreciate that.
It did, yeah.
You know what, guys, don't forget to go after this is over and review. Take quality notes over what we shared because you have a knowledge check over the quadratic formula and rational expressions. And then they also have a quiz covering the homework of exponent rules and the other concept we talked about today. Do you remember what that was?
Radicals?
Radicals, that's right.
And as always, if you have any questions, please reach out to us through our email.
Or our social media site.
Called Google Classroom.
Yes. And I am Miss Kim Flowers, and this is
Mr. Ronnie Flowers, and we are Geometry News Network.